Thank you, Vimal. Now I'll be talking about two types of materials we consider for a solar cell, aluminized mylar and CP1. Both of these materials are relatively close in thickness, density, and reflectivity, but in the end we decided to go with aluminized mylar for several reasons. It's smaller in thickness, it's cheap, it's accessible, and we have experience with the material. We also know how it behaves when folded and how easy it is to tear. As for CP1, as much as I would love to work with a space made material, it just isn't very accessible to us. We have to request it from a company called Nexel, and that's if they want to sell us the material. As mentioned earlier, aluminized mylar does tear easily, so we will be applying Kapton tape to our sail. A rep saw method will be implemented that will add 4 quadrants to each side of the sail. In the worst case scenario that the sail does tear, this will prevent further tearing from happening and keeping the tearing to just that quadrant. So now let's talk a little bit about the folding patterns. Folding pattern number 2 is just very time consuming. We don't want to spend our entire time folding the sail. Not only that, its member strength isn't very high and extra tension is required in order to compensate for that. As for folding pattern number 2, yeah, it's very easy to fold, but its member strength also isn't very high. And that's due to all the lines converging at one point. As for folding pattern number 3, it has almost no flaws other than the fact that it requires a large amount of space to be stored. Folding pattern number 4 is the folding pattern we decided on. It requires very little space to store, and it helps with the booms, and it's very durable. We can also control the height and the base that it would be folded down to with equations that we came up with. For folding pattern number 5, we require 4 independent cells for our attitude control method. Folding pattern number 5 just uses one giant cell, so by default we can't use this folding method. So now, after we've chosen our material and our folding method, we decided to make prototypes, prototype 1 and prototype 2. Prototype 1 has a base of 1 meter and a height of 0.9 meters, and it was folded down to a base of 0.11 meters and a height of 0.07 meters. However, this prototype ended in a failure due to deployment failure. As you can see in the top left, when we tried deploying this thing, it ended in failure due to binding. So we had to make a new prototype, prototype number 2. And after improving our procedures in applying Kapton tape, measuring the length between creases, tensioning the sail, and how we even folded the sail, prototype 2 came out much, much nicer. Prototype 2 has a base of 1.43 meters and a height of 0.71 meters, and it was folded down to a base of 0.10 meters and a height of 0.048 meters. We were actually able to reduce the base and the height from prototype 1 to prototype 2, and as you can see, it deploys very smoothly. So just for a better visual representation for you guys, we've deployed this cell about 13 times and we refolded it about 13 times. It's very quick to refold and it's very durable. So now I would like to hand it off to Andrew, who will be talking about the booms.